Hello, my name is Kendall Frederics, and for Serve 2020, I will be presenting a poster. My research is on can eBird serve as an adequate surrogate for field observations in assessing the prevalence of virally competent avian hosts for West Nile virus. So, for a little background on West Nile virus, the virus was first isolated in Uganda and spread outward from there. It made it to North America in 1999 and is still prevalent today. The disease is a mosquito-borne virus and poses a risk to people, livestock, and avian populations. Due to the potential ramifications associated with the contraction of the disease, assessing risks remains significant on ongoing research. The pathogen is dependent on viral amplification between virally competent host species and mosquito vectors. Specifically, avian species with moderate to high competence can serve as biotic reservoirs for the virus, allowing for the continuation of infection in succeeding years. Along with other influential factors, the knowledge of which bird species predominate specific locations can help and provide the general public with a viable forecast. And this indicates the probable presence of the virus. So if somewhere, for example, you know the bird species within a certain location, you're able to predict the likelihood of the prevalence of the virus, and you can give the general public a heads up before infection actually occurs. So, in order to do this, point surveys must be conducted. And although point surveys remain optimal, comprehensive studies across the entire state of Montana remain impractical. I mean, if you think of it, Montana is extremely large, and in order to conduct surveys at every location in which we are receiving positive results for West Nile, it's extremely unlikely because it's would be extremely intensive and also extremely expensive. So in order to combat this, a citizen science database, an application called eBird, may have provided a solution for this. To evaluate the credibility of the software application, this study aims to determine if eBird data can serve as an adequate surrogate for field observations. With respect in methodology, 15-minute bird surveys were conducted in the field to compare with eBird's database. Over the course of 2 summers, 2018 and 2019, this data was collected at mosquito trap sites, and this includes Lake Helena, the Helena Police Academy, and the Helena Regulating Reservoir. And if you look towards this picture, you can kind of see this is Brandon and I conducting the point surveys at Lake Helena, and I believe this was in 2018. So then after that, I was able to compile eBird data at the same locations, and then I could conduct linear regression analyses to distinguish potential correlations. Specifically, I looked at avian species with medium to high competence. So in terms of results, again, I completed regression analyses, and specifically, I compared the relative abundance yielded from my own data, and I compared that with the relative frequency provided from eBird. So as you can see, every site produced significant correlations. However, some revealed stronger relationships. For example, if you look at Lake Helena and the Helena Regulating Reservoir, there was more of a correlation here than what occurred with Police Academy. And if you look at Police Academy, you can see the graph is a little weird, and we believe that this could possibly be due to lack of data. Okay, so in reference to Table 1, I also performed a linear regression on all bird data, not just the moderate to high competence, and this was done on a week-to-week basis within our study. So again, significant correlations were also produced, and you can see again, Police Academy did not yield as many significant correlations. And again, we think this might be due to lack of data. And so in order to visualize this research just a wee bit better, I provided some imagery. This right here is a photo of a robin, and although they're extremely common, they're also extremely virally competent. Shane Sater actually took this photo, And I just like that it displays that these are among the many virally competent species. I also constructed a map that displays the various mosquito trap sites. You can see here's Police Academy, Lake Helena, and the Helena Regulating Reservoir, and these are all sites within the Helena Valley that are very close to one another. And if you notice, there's like a little sundial icon, and that shows where we've yielded positive West Nile virus results. So again, we chose these sites because they were yielding the positive results. So in conclusion, over the course of the weeks, or over the weeks that which were compared, they showed significant correlations between the data sets. This indicates that eBird could be implemented with confidence as an assessment of viral reservoirs at these specific sites. So specifically in these locations, it could be used. eBird could be used as a surrogate. Again, in some cases, there were stronger relationships or correlations demonstrated, and reasons as to why this may occur may be due to lack of data. For example, eBird compiles data based off of, it compiles it most efficiently off of hotspots. So in this case, there was a lack of recorded observations at the police academy. So what needs to happen here is we need to encourage others and other individuals, especially birders, to go out there and record their findings on the software application to kind of benefit this research and the surrogacy or potential surrogacy of eBird. So in terms of acknowledgments, I would really like to thank Dr. Hokett and Dr. Glowinka for their support throughout the West Nile project and for my own personal research. I would also like to thank fellow undergraduate students Brandon Brown and Shane Sater. They were extremely incremental and provided tremendous help to my research. This research was also funded by an award by INBRI and an award or scholarship given by the Last Chance Audubon Society. So huge thanks to them and all their contributions. And yeah, that's my presentation. Thank you. Have a good day.